Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler, and today I will show you how to solve a simple problem related to the relative motion and relative speed. So first of all, the introduction of this concept, of this idea of relative motion, you can find it in my previous video, which should be available here on top and in the below the video in the description. And there you can also find the text of this problem. So, but I will read it anyway. The tourist rented a kayak and had to return it at the same point. First, he kayaked 10 kilometers up the river, so against the current. So let's say the current of the river is in this direction, and let's call the speed of the current to be W. And this took him 3 hours. Then he returned kayaking with the current in 2 hours. So it's time t1, time t2, and distance s is 10 kilometers. Calculate the speed of the river, so W, of the speed of the river current and the kayaker's speed relative to the water. Yeah, so it's all about frames of reference. So we have one frame of reference related to the surroundings, to the edge of the river, or let's say to the tree which is next to the river. Okay, so in this frame of motion, frame of reference, the speed of the current of river is W. But you can also think of another frame of reference connected with water of the river, so moving with river. So in this frame of reference, the current speed is 0, and the the speed of kayak, let's call it V. So this will be the speed of kayak in the frame of reference of the river. Okay, so if you do this, what will be the speed of kayak in frame of reference, so relative to the tree next to the river? So if he goes against current, then the arrows, the velocities are in opposite directions. So this speed would be v minus w, and when he goes with the current, then the speed then the current of the river helps him, so he moves faster relative to the edge of the river, so his speed is v plus w. All right, and in this case we can of course assume that the speed is constant, so the motion is uniform, so speed can be calculated as distance divided by time. So distance here is s, and time when he goes against current is t1, and in the second situation distance is the same, but time is different, t2. So these are two simple equations which form the simple system of equations which you can solve because you have two unknowns, because, well, s, t1 and t2 are all known in this problem. So you can, I think in this case we can solve it by plugging in the numbers. So v minus w is, s is 10 over 3, so it's 3 and 1/3, so it's approximately 3.33, and here v plus w is 10 divided by, oh sorry, 5 is solution is answered, it's 10 divided by 2, and this is indeed 5. Okay, so this is our system of equations, and it's convenient to add them, which means I add left hand side of the first equation to the left hand side of the second equation, and right hand side of the first equation with right hand side of the second equation. This I don't need anymore. So v and v, we have 2v, but the trick is that minus w plus w cancels out, so we have only one unknown on the left side, so it's approximately 8.33, so you just divide by 2, and v is approximately 4.16 watt kilometers per hour. That's the speed of the kayak relative to the water. And w you can calculate out of one of these equations. I guess this will be simpler. So you have v plus w equals 5, and you know v is 4.16, so w is approximately 5 minus v, so 5 minus 4.16, so it's 0.84 kilometers per hour. That's all about this. So the idea is that the speed relative to the edge of the river is obtained by subtracting when he goes against the current, and you add these two speeds when he goes with the current, and then it's just speed equals distance over time, and then it's solving mathematical calculations. So that's all about this problem. In next videos I will show you another problems related to relative motion, so I invite you to check them.